So in this video, we are going to discuss about 4-bit asynchronous counters. So for that one, you have to go to File, click New Project, then click Next. Okay, click RTL project, then select basys3, click Next, then click Finish. So create a design source. Okay, create a file name as JK, and then click Finish. So JK flip-flop program, I have it here. So just I'm copying this program. And I'm pasting it here. So module JK flip-flop, inputs are clock reset, then JK, okay, then output register Q, then Q bar. Okay, so always at the positive edge of the clock or negative edge of the reset, begin. If reset is 0, output goes to 0. Okay, then else, okay, begin case JK. If the JK value is the JK value of the flip-flop is 0 0, Q is equal to Q. If 0 1, Q is equal to 0. If 1 0, Q is equal to 1. If 1 1, Q is equal to not of Q. Okay, end case is for this one, then this end is for this begin, and this end is for this begin. Okay, otherwise assign Q bar is equal to not of Q. Okay, end the module. So you save this one. Then run synthesis. So next I'm going to write a program for up or down counter. Okay, so I'm just copying this program, then click design source, add or create the design source. So up down counter. Okay, up down counter, click Finish. Okay, so I paste it here. You can see here module up down selector. Okay, so input is Q and Q bar, and input is UP, output is N clock. Okay, so assign N clock is equal to if up value is 1 means Q bar is selected. Okay, so if the Q bar is going to the input, if the Q bar of the one flip-flop is going to act as a clock for the next flip-flop, then it will act as up counter. If Q is going to the next flip-flop as a clock means it will act as a down counter. So for this you have this program. Okay, so next I'm going to create another program. Okay, this is my actual program. Okay, I'm giving it as asynchronous. Okay. So next I'm going to copy this program. In this I'm going to paste. So asynchronous, the module asynchronous counter is a name. Okay, the parameter size, the size value is equal to 4 since I'm going for the 4-bit counter. So input clock resetting, then JK up, input up value, output is equal to, output is 3 is to 0. 3 is to 0 means 0, 1, 2, 3, 4. So 4 values. Okay. Then Q and Q bar. Okay, so the wire value of this wire value is nothing but 3 is to 0. Okay, so general variable I have assigned it as G. Okay, so I'm going to call this JK flip-flop. Here I have given it as JK flip-flop, so I'm going to call this JK flip-flop. In the JK flip-flop I have clock resetting JK, Q and Q bar. So in, for first value this clock resetting JK, instead of Q bar Q I have to give it as Q of 0, and this is Q bar. Okay, then generate. Okay, for loop, we have to create a for loop. So for the for loop, for G is equal to 1. Okay, when now G is equal to 1, it will begin. Okay, then it will select the up down counter. Okay, so you can see. So for for begin gen flips. Okay, gen flips up down counter. So what does this so up down counter is the name of this this program, up down counter. Up down counter, and I have given the name it as UD select. Okay, so here you can see the Q values. Now Q of if I substitute G value is 1, Q of 0. Okay, so since up down counter value is Q bar up and N select. Okay, so first I have to select for this one Q of 0. Okay, Q of 0 and Q bar of 0 up and N clock of 0. Okay, okay, so JK flip-flop in the JK, so I have to give N clock of 0. Okay, N clock of 0 as a input of the next clock. Okay, then reset in JK JK Q of 1, Q of 1 and Q bar of 1. Okay, so next it will go to 2. Okay, so next it will go to 2. Then it becomes Q of 1, Q bar of 1, then N clock of 1. Okay, so here it will come at as N clock of 1 or resetting JK and Q of 2, Q bar of 2. Then it will go to N clock of 2 RSTN JK Q of 3 and so it will stop up to Q of 2. Okay, Q of 3, it will go up to Q of 3. Okay, Q of 3 and Q bar of 3. So let me save this program. So if I save it has to become the top module. Okay. Then you save this program, run synthesis. Okay, click OK. And next I'm going to write a test bench program.
That's still the version.
Then in the source you click create design source. Then you press test.
You know about Larry.
So you save this program. So module TB is my name, register. Instead of input you have to give it as register. Then wire for output. Then you have to call this program asynchronous count hash of 4. Okay. And then these are my inputs. Okay. And output initial begin. So the clock value is 0 initially. Then reset value we will 0. So after that up value is 1, JK value is 0. After 4 nanosecond reset is 1, JK is 1. Okay. So you can give whatever the value you want. You save this program. And then for this one, you run simulation. So if you run simulation, you will get the output like this. Okay. So you can see the program. So initially the clock value is 0 and reset value is 0. Up value is 1, JK value is 0, 0. So reset value and clock value is 1, JK value is 0, up value is 1. Okay, therefore the Q value is 0 and Q bar value is F. Sorry, F. Okay. So what is the next condition? Next condition is reset value becomes 1. If reset value becomes 1, JK value is 1, 1. Okay, if JK value is 1, 1 means it will start to up count because up value is 1 here. Okay, then it will goes on, right? 2, 3, 4. Okay, so why this is going to 0? Because the reset value is going to 0, goes to 0. Okay. So next, if up value is 0 means down value is 1. So from 0 it goes to F. Okay. So it is working properly. Next, let me go for the clock divider program. So create the clock divider. Okay. So this is my clock divider program, and copy this one. Terminate. Save it here. Clock divider input clock register counter always. This I have already explained to you. previous videos. Save this program. So I need to create the top module for this one. So the top module is more same as this one. So let me copy and onto this program. Okay. So what are my inputs in the synchronous clock? Input clock. Okay, input clock. Input RST underscore in. Then I have JK. Input wire J. Input wire K. Then I have upper output size then
AI.
Q and the Q bar. Output wire Q and Q bar. So let's copy this one also, size to C. So the clock divider is same as the sun clock. Okay. Then this clock is given to my asynchronous counter. So what is the name of this one? Asynchronous counter. So it is written as clock, and this clock is given as an input of this one. Then I have reset in, right? Reset in. Then you have JK. Then you have up. Q and Q bar. K. That's it. So now this becomes a top module. Okay. Now I'm going to generate a constraint file for this one. Completed. These are my constraint file, and I have completed this with Steam. Then I go to open hardware manager. Okay, click open target. Then click program devices. Then start to program. Okay. So initially what I'm going to do is this JK is 1 okay, and the reset pin is 0, okay, and then up value I'm going to make it as 1, okay. So if reset, if it goes to 1, it will start to up count. After you can see, if it goes up, this is my reset pin. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So if I bring the bring this up counter as down counter, so it will start to down count. It will act as a down count. Okay. So these 4 pins are my Q and these 4 pins are a Q bar.